Hello friends, Namaste one and all. Welcome to our session. How are you all? I hope you guys are doing great. Yes guys, do you know what is Gauss law in electrostatics and how to find flux through a cube? In this session, we will discuss briefly about these points. What is Gauss law and how to find flux through a cube by using Gauss law. Are you ready guys? Take pen and paper as try to copy the points along with me. Yes, let us get into the concept. Let's see here guys. Just a second. Right. Yeah. So welcome to our channel, and if you are new to our channel, please don't forget to click on the like button guys, and especially click on the subscribe button. If you are new to our channel, click on the subscribe button and support us. Okay, and don't forget to click on like button if you like this video. Okay guys, let us get into the conceptual discussion. What is Gauss law? Gauss law in electrostatics. Gauss law, let us see first the statement. Gauss law states that if you have any closed surface, it may be any regular shaped closed surface or irregular shaped closed surface, like it's a three-dimensional surface we are discussing. Okay, so if you have any closed surface and if this surface encloses some charge, that charge may be here or here, anywhere within this. If this surface encloses some charge, then Gauss law states that some flux will passes through this, crosses this surface, and the amount of flux, if it is a positive charge, we know that the electric field lines are radially outward. Electric field lines will be radially outward, right? Electric number of field lines. What is flux? We know that the number of field lines crossing a unit area normally gives electric flux. So Gauss law here says that the flux through any closed surface called a Gaussian surface is equal to 1 by epsilon naught times 1 by epsilon naught times the charge enclosed. You can express it as enclosed charge. Q in means charge inside the surface. So you can write, or simply Q by epsilon naught you can write. The statement, we can write it as, try to write down this everyone. The statement of Gauss law. The flux through a closed surface, the flux through a closed surface called Gaussian surface, is equal to 1 by epsilon naught times the charge enclosed by that surface, charge enclosed by that surface or by the surface. Is it clear? So the flux through a closed surface called Gaussian surface, we also call it as imaginary closed surface, is equal to 1 by epsilon naught times the charge enclosed by the surface or by that surface. So therefore mathematically it is given by, you can say mathematically it is given by flux phi is equal to 1 by epsilon naught into Q enclosed or Q inside that closed surface. This is the mathematical expression for Gauss law. So Gauss law gives flux through a closed surface. Is it clear guys, everyone? Right? Now let us try to understand how to find the flux through one of the closed surfaces called cubes. Okay, let us consider some examples. With the help of some examples, we will try to understand this concept. If a point charge plus Q is placed at the center of a cube of side L, then electric flux emerging from the cube is. So let us consider a cube. Yes, let us say this is a cube right? So this is a cube, and a charge Q is inside this surface. A charge Q is here. Some charge Q is at the center. So electric flux emerging from the cube, in which case, if a point charge Q is placed at the center of the cube, outside L, right? In this case, what is the flux? Electric flux emerging from the cube. In this case, from the Gauss law, directly you can say from the statement of Gauss law, flux is equal to 1 by epsilon naught times the charge enclosed. How much charge is enclosed? Q. So it is directly equal to Q by epsilon naught, right? So which option is that? First option is the right one. Is it clear, guys? Right. Next question. The flux through any one face of the cube is. The flux through any one face is. So in the above question, the flux through the entire cube, the electric flux emerging from the cube means from the entire cube is Q by epsilon naught. So cube will be having how many faces? You have to, you should visualize this. Cube will have 6 faces. Like you can observe your room where you are sitting. Room is nothing but like you can consider, imagine the classroom which you are sitting is a cube. Okay, it will be having right side wall, left side wall, and top wall, bottom on the floor which we are sitting is one surface, and front wall, back wall are the faces. So these 6 faces, you can say 6 faces forms the cube. So the flux through all 6 faces, is 1 by epsilon naught into Q, or Q by epsilon naught. Through one face, if you want, you will get flux through one face is equal to 1 by 6 times Q by epsilon naught. So that is the flux through one single face. Through all 6, through a cube means through all 6 faces, the flux coming out is Q by epsilon naught. Through one face is 1 by 6 into Q by epsilon naught. Is this clear, guys, everyone? So which option is right now? Q by 6 epsilon naught is option 4, right? Very good. Next, let us see another question. So if the charge is kept at the center of a face, in previous case at the center of the cube we kept the charge. Now the charge is kept at the center of a face. Okay, then what should be the in this case what should be the flux? We have to find out. So in this case, if you observe this again, the given description here, if the charge is kept at the center of a face, in such case, to find the flux, we have to first we should enclose the charge by assuming a Gaussian surface. So identical imaginary cube we have to construct here. So the question is, in the above case, means when the charge is at the center of any one of the face, it may be right side face or left side face, front face, back face, top face, down, bottom face, any face at the center of any single face, then flux through the given cube. To find the flux through given cube, here you know that flux will be emerging. Flux emerges in all the 360 directions, 360 degrees directions, right? So half of the flux may pass through this cube, but on the right side part, you see here, on this right side part, there is no cube encloses this flux. So for enclosing this entire flux, you have to construct an identical imaginary cube. So like this. Is that clear, guys? To find the flux through a cube, you have to construct an imaginary cube, identical imaginary cube. Now you can say that now the entire flux coming out is enclosed by these 2 cubes. How many cubes? 2 cubes. So the total flux in this case, total flux phi is passing through 2 cubes. How many cubes? 2 cubes is equal to 1 by epsilon naught times the charge, or Q by epsilon naught. Whereas we are asked to find what is the flux through the given cube. In this case, in the only given cube, through the 2 cubes, Q by epsilon naught, through only 1 cube, half of the flux only will pass us. Is that clear, guys? So half of this means 1 by 2. So through one face, through 1 cube, this is 2 cubes. Through 1 cube, it is phi is equal to half of Q by epsilon naught, or Q by 2 epsilon naught. So your correct option should be this. Q by 2 epsilon naught is the flux through given cube. I hope you have understand this. Next question, let us see. Next question. Yes, sir. Guys, try to copy it down and practice yourself. Okay. You can pause the screen and you can practice it. Next one. In the above case, the flux through one phase. What is this one phase? We have discussed about through one cube. No, through one phase. Means try to go through the diagram once again here. Through one phase. So here is the charge at the center of one phase of a cube. Through one phase, how much flux is passing through? Through one cube, the flux passing through is q by 2 epsilon naught. So through one phase, how much means? What does that means is, here when you are having the charge at center of the phase, the flux lines on this surface will grazes that surface. So they will not crosses normally. So we can say this surface at this phase will not contribute for flux. What is by definition? What is flux? Number of field lines crossing normally through the surface. So on this surface, field lines will grazes or passes parallel to the surface. So this surface on which it is locating will not contribute for flux. So how many phases it will be? Cube will be having 6 phases. Out of those 6, one phase you have to leave it. So remaining 5 phases will contribute for the flux. So in one cube, through the flux through one cube is this much, means how many phases are contributing this? 5 phases. The flux through 5 phases is flux through 5 phases is nothing but q by 2 epsilon naught. Flux through a given cube is this much, means this is through 5 phases. Through 5 phases. Through one phase, if you want, through one phase, then you have to divide this by 5. That means q by 2 epsilon naught. 1 by 5e, 1 by 5 into q by 2 epsilon naught. This becomes q by 10 epsilon naught. This is the flux through one phase or single phase. Flux through one phase is q by 10 epsilon naught. That means option 3 is correct. Is this clear, guys? So try to, if you want to listen again, just actually go before the starting of the discussion of this point, and again try to listen it, and you can understand this. Okay, if you are already having the concept, you can just simply can go ahead with this. Okay, next let us try to see the next conceptual point related to this is, if the charge is kept at the corner of a cube, then in this case and the above case, flux from the given cube is, so this is a given cube, given in A is a cube, given cube. In this cube, charge is kept here at the corner of the cube. At this corner it is kept. Now, what is the flux through this entire cube is the question. So first thing what you have to understand, or what you have to do is, you have to enclose this charge, given charge, by an imaginary surface called Gaussian surface, identical Gaussian surface, because this this shape is cubical shape. So similar identical cubical with identical means with cubical shapes only, we have to enclose this. For that purpose, what you have to do is, if you say this is a cube and here is the charge, you have to construct one cube here, right, and one cube here. Here we have to construct one cube. So side by side, 2 cubes will come here, and here the flux will be going here also. To cover that, you have to construct one cube here, and to cover the flux here, you have to construct one more cube. So how many cubes are there? 1, 2, 3, 4. So these, because the charge is at the corner, these cubes will cover first half of the front face, and again back side. If you imagine, the remaining half of the flux will be passing on back side. So to cover that flux also, same number of cubes you have to construct on back side. That means how many? 1, 2, 1, 2, 3, 4. So these many cubes you have to construct on back side also. So four more cubes, that is given here, that is shown in here, right? So total, to enclose this charge, total number of cubes you have to construct is nothing but 8 cubes. 8 cubes will encloses this charge. Is that clear, guys? 8 cubes. So now you'll get an entire closed surface, Gaussian surface. The Gaussian surface is created by 8 cubes. So now the flux through this through all these 8 cubes is nothing but 1 by epsilon naught times the given charge q. So flux through 8 cubes. Flux through 1 cube is how much? Flux through 1 cube is, this is flux through 8 cubes. Flux through 1 cube is 1 cube is equal to 1 by 8 times q by epsilon naught. Is this clear, guys, everyone? Next, the question is flux from the given cube. Yes, that's all. Only through the given cube only asks. So that means the only 1 cube is how much? 1 by 8 times q by epsilon naught, or q by 8 epsilon naught. Q by 8 epsilon naught. That means option 3 is the correct one. Got it, guys? Next, based on this only, we will do one more question here. So in the above case, the flux through one phase opposite to the charge is, means, again go back to the figure. So here is the what do you call the charge. Let me erase this. Already have copied this, right? So now for understanding purpose, I am erasing this now. The written part of written cubical parts here. Yes, you see here. The charge is here at this corner. Now the question is, what is the flux through one phase opposite to the charge? Opposite to the charge. So opposite to the charge, the phase which is opposite to the charge is this corner, means so somewhere here, this phase, right? Opposite to this. To find that, I can also say through only one phase. You should know how many phases are contributing this flux. Flux through one cube is q by 8 epsilon naught. In this one cube, how many phases are contributing this flux? To understand that, you have to carefully follow here. How many phases are linking with this? How many phases are linking with this charge? You have to understand first. So this phase is linking, right side phase, and top phase is also linking directly. Means the flux through this will be not crossing normally. This will be grazing through this parallel. This will passes parallelly to this surface. Also, it will passes parallelly, and the back face also, and the back side face also, it passes parallelly. So out of 6 phases, through 3 phases, the flux passes parallelly. Only the remaining 3 phases will contribute this entire flux in this. So we can say that only one cube, in one cube, 3 phases contribute for flux, and the flux through 3 phases is q by 8 epsilon naught. Is it clear? Whereas flux through in the next question, right? Here flux through cube, one cube means flux through 3 phases is equal to q by 8 epsilon naught. Q by 8 epsilon naught. If you want through one phase, flux through one phase is equal to 1 by 3 times this, that is q by 8 epsilon naught. It is equal to how much? Q by 24 epsilon naught. I hope it is clear for you guys. I hope you have understood this. Next, let us go to the next related question. See here. Before going to this, here itself, I would like to give you one more additional question. Let us say the question is, if the charge is placed at the center of vertex, or center of an edge. Let us say this is an edge, this is one edge, this is another edge, like this is another edge, this is an edge. So this is one space, right? So if the charge is at the center of an edge, this is an edge, right? Here, if the charge is here, then again 2 questions I am giving you. First question is, what is the flux through the entire cube, given cube? And next one, what is the flux through one face of this cube? To understand this, again, we have to remember that you have to enclose this charge. For enclosing purpose, when it is here on this corner, some flux will be coming outside, which will be a part of the flux will be going through this. So to cover this, we have to construct one cube here. If you construct one cube, if it is here at the center of this face, it will cover the entire flux. But if it is here, only half of the flux will be covered. So by these 2 cubes. So to cover remaining half, you have to construct one cube here on the front side, one more cube here on front side. So overall, so now we can say that these 4 cubes will cover this entire charge to be inside. So the entire flux through 4 cubes is is equal to q by epsilon naught. The total flux is nothing but flux through 4 cubes, whereas flux through 1 cube is equal to 1 by 4 times q by epsilon naught. Is it clear, guys? And in this, now just I would like to erase this. Let me draw this once again. This is our cube, right? And charge is here, right? When charge is here, through the single cube, the flux is 1 by 4 into q by epsilon naught. Means how many phases are contributing this? In this single cube, how many phases are contributing? So the phases which are linking with will not contribute. Means this phase and this phase, only 2 phases are linking with this, right? This top, bottom one and the back one are not linking with. So out of 6 phases, 2 phases are not contributing, means 4 phases are contributing. So the flux through 1 cube means flux through 4 phases is q by 4 epsilon naught. So flux through 1 phase is 1 by 4 times q by 4 epsilon naught. That means it is equal to q by 16 epsilon naught. So like this kind of questions will come across based on a flux through cube. Is this clear, guys? What kind of questions comes and how to work out these questions? I hope you guys have understood clearly. Next, let us see a similar kind of question. Right? See here. If in this case, it is given that in a region, electric field depends on x-axis as E equal to E naught x square. E, there is a cube of edge as shown in figure here. Then find the charge enclosed in that cube. Then find the charge enclosed in this cube. So actually this cube is kept in an external electric field. It is not uniform. It is varying with x. It is depending on x-axis. Means your x changes. X is equal to 1, 2, 3. If you change x is equal to 1 means E equal to E naught. X equal to 2 means 2 square is 4 E naught. Like that, E is changing from point to point and along x-axis, and it is directing along x-axis. In this case, what should be the charge enclosed by this cube, which is placed at this is 2a at a 2a distance. 2a distance. Is it clear, guys? So to work out this kind of questions, you have to first understand that net flux usually through any enclosed surface is q by epsilon naught. Here in this case, because of the field, some field is directing like this, means some field will entering here, some field is leaving here. Because it is not uniform, a distance of x equal to 2a, this is x equal to 2a, field will be having some different value, like E1 you can say. And after this a, then x at this point x becomes 2a plus a, 3a, the field at this point will be E2. So because field is changing, flux also changes at these 2 ends. So the flux entering or flux which is entering means the flux directing into the cube plus flux coming out of the cube. Sum of these two will give you the net flux. But the flux leaving the cube will be taken as positive, and which is entering will be taken as negative because of this sign conventions you can understand here. Where phi in is flux which is entering inwards, is a vector. By definition of flux, you can write it as E vector dot A vector. It is in vector form. If you write it is, you can express it as EA cos theta. In this case, when it is entering here, electric field direction is to the right, but area vector will be along outward normal. This will be outward normal area vector. So angle between them is 180. So cos 180 is minus 1. So you can write it as minus E into A, magnetic product of magnitudes of this, minus EA. So minus E is E naught into 2a square at this point. The distance of 2a is minus E naught into 2a square into a. Area of this face is length into breadth, that is a square. So that gives you minus 4a power 4. Here 2a square becomes 4a square into a square becomes a power 4. So minus 4a power 4 E naught is the flux entering into this cube. Whereas flux leaving out of this is E out into A cap. It is equal to, because here electric field is in this direction, area vector will be along the outward normal, both are in parallel direction. So here flux will be EA cos theta, theta is 0, so EA only. So E at this particular point is E is E naught into x square. X is 3A. For this particular point, 2A plus A is 3A. So 3A whole square is E becomes E naught into 3A whole square into area is A square. So that becomes 9A power 4 E naught is the flux coming out. So therefore net flux is E in plus E out is equal to 9A power 4 E naught minus 4A power 4 E naught. So that gives you 5A square E naught is the net flux. But you are asked to find in this case what would be the charge enclosed by the cube. So net also from Gauss law we know that net flux is equal to Q by epsilon naught or 1 by epsilon naught times the charge enclosed. So this 5A power 4 not A square is A power 4 5A power 4 E naught is equal to Q by epsilon naught. From this Q is equal to this into epsilon naught. So 5, all right. So 5 epsilon naught A power 4 into E naught. Which option is the right one? The first option is right. Is it clear, guys? So like this, you have to deal with the questions related to cubes and a flux calculation through cubes. I hope it is clear for you guys, right? And if you like the video, don't forget to click on like button. And if you are new to the channel, please subscribe the channel and support us, guys. Okay, then take care, everyone. Take care. Bye bye. Jai Bhim and Jai Hind.